Here we can see more examples of the R format instructions. So for example, we've seen the logical operations such as AND, OR, NOR, or XOR. So these are all R format and they're exactly the same in machine language and assembly. Shifts also are the same exactly. So we've seen this one that we are doing, for example, shift the bits all to the left or to the right, and all that are basically similar. But this is just some examples that you know these are our instructions. And the first kind of sign that you know that this is R is because it has two registers. So let's look at how actually these R format instructions are formed and how the bits are laid out. So the first thing is that our operands that we have are in registers. So we have a operation, so it could be add in this case, and here we have 3 registers. So that's a general format on our instructions. We saw some that had two registers, and that only means that one of them is basically empty. So it would be zeros. So this is the bit pattern. So we have 6 bits for the opcode or operation code. So that basically this 6 bit, it's kind of like letting the CPU know which instruction we are dealing with. So each instruction has a code. Some of the instructions, especially in the R format, we have an extended opcode also. So these two together in the R format only, these two together are going to specify which instruction is being executed. So we have 6 bits here and 11 bits at the least most significance. So actually in the R, this 6 bit, we're gonna see in the later slides that these 6 bits are actually set to 0 always. So that's another way that you know that one instruction is actually R format. So all the bits is set to 0. So that taking the 6-bit and 11-bit leaves us with basically 15 bits. And we see that here we have the 3 registers and each gonna take 5 bits. So one thing to notice is that the order is not the same. So here we have RD, RS, and RT. So if we say D, S, and T, here we have S and T first, and then we have D after those. So the order is not the same. It's just something to notice. And that is because of basically it goes more into the implementation of how they decided to design this processor, and this formatting works with the best basically. So it's more compatible with the other formats and other instructions. But you don't need to worry about that at this point. So just to recap, we have the opcode, so 6-bit, the left most significant bits, and 11-bit for the still opcode for on the lower significant bits. And then the 15 middle bits that we have is going to be basically the registers. One more thing that I want to add is that you can pause the video and think about it for a few seconds. What is the reason that there is 5 bits here for each register? So why is exactly 5 bits? So the reason is that we have basically 32 bits or 32-bit different register that we could represent here. And if you convert 32 to binary, you can represent that with the 5 bits basically. So it's from 0 to 31. And that is the reason that the largest number that you need to represent this register is actually, you can represent that with only 5 bits.